Okay, I'll try and keep this short. A video about transformations and vertical stretch and vertical compress. This is something you know already, we just haven't talked about it since September. When we're talking about transformations of the parent function, the parent quadratic function, we're usually looking at them in vertex form, and then we're asking what sort of transformations were made here compared to the parent function. So a really easy way to get a sense of what's going on is to use the calculator and just put them both in and compare. So there's x squared, and then here's the other, x minus 7 squared plus 4. And the goal is just to be able to look at this and know what the transformations are, and I'll talk about that in just 1 minute. But first, let's look at the graph. There's x squared, and there is our transformation. And so what all we need to do is look at the vertex and ask ourselves, how much did we go over and how much did we go up? Or had it been a different transformation, how much did we go left, how much did we go down? Basically, how did the vertex move? Where did the vertex move? And of course you know that already because this is in vertex form. You know the vertex is 7, 4. So all that means is that we counted over 7 units and up 4 units. So that's the transformation right there. We went to the right 7 and up 4. And if you're wondering why we have that reversal inside with the x, the question is what value of x would bring this back to 0? And if you put in the opposite of -7, which is +7, this middle term is 0 again. And then we're back at the center, and that's where the vertex is. It's just sort of something you get used to. The x is the left and right, and the transformation is the opposite of that sign right there. It's 7 to the right. And then the one outside the parentheses is very straightforward. If it's +4, it went up 4. If it was -4, then it would have gone down 4. So that's the transformations. And we learned this in September. It's just been a while since I asked you to think about it. The next one you know already. It's about the value of a. We've just changed the vocabulary a little bit. Vertical and horizontal stretch and compress. So when a is greater than 1, we've got a vertical stretch or a horizontal compression. And let's just see what that looks like. Again, we're talking about relative to the parent function. So if I leave my parent function in there and change it to 3x squared, so my a value is greater than 1, and I graph it, you can see the quadratic parent, and then you can see this much more narrow version of the quadratic inside. And just think about it. This is either horizontal compression, that is we've taken the parent function and just pressed it in, or it's vertical stretch. We've taken the parent function and we've stretched it out so that it got more narrow. So it's really just a matter of vocabulary and using your imagination. There's not anything to memorize here. If you horizontally compress, it gets skinnier, and that's the same as vertically stretching to make it skinnier. And then if we use an a value that's between 0 and 1, we're going to reverse everything. It'll be a vertical compression or a horizontal stretch. So here's an example. Again, using x squared, and this time we'll use 1/3 x. Instead of 3x squared. Look at the graph. There's the original parent function, and then there is our transformation, and you can see that's the same as a horizontal stretch. We just stretched the function out, or a vertical compression. We squeezed it down so it got wider. So it's something you know already. We're just changing our vocabulary a little bit away from more narrow or more wide, and using these words horizontal compression and vertical compression, or horizontal stretch and vertical stretch. And I encourage you not to memorize that. Use your graphing technology to look at the picture, and then use your imagination. This has been stretched out horizontally, or squashed down, or compressed vertically in order to make it wider. So there you are. I hope that helps. The quiz is for homework. The code is 884229. And there's at least one question in there where the right answer is not actually the right answer according to the program. It's a mistake. But don't worry about that. If you get everything correct, you should have a 95 instead of 100.